Just like what the title says, data classifications, different ways to classify data. So these next couple of sections, we are going to be going over some terms that you have probably heard before, and then we're going to go over some terms that I guarantee you, unless you've had a research class or another statistics class, you've never heard before. All right, and so one way to classify data is by classifying it by discrete or continuous. So we have discrete data and we have continuous data. So what's the difference? Think about in your mind where maybe you've heard the word discrete. There's even a math class called discrete mathematics. We don't teach it here, but some universities do. Discrete, that's data in which the observations are restricted to a set of values. That possesses gaps. Okay, so let's think about what that means for a second. So, for example, if we took the heart rate of everyone in here, usually heart rate is given in, 80 beats per minute or 60 beats per minute or 120 beats per minute. We always, if you work out, usually there's some type of heart rate goal that you're working on. If you're on some kind of bike or you're on whatever, you're running. I only run when something's chasing me. But if you're on a bike or an elliptical or something like that, and you try to get that heart rate up, and maybe you measure it every day, well, just generally the way that we measure heart rate or cholesterol or a lot of things with the body, really, we use whole numbers, right? And so there are gaps, usually. And so my heart rate may be 90 beats per minute right now, and then maybe when I work out it goes up to 150 beats per minute. So I'm generally not going to measure my heartbeat and say, okay, it was 90.256 beats per minute, right? There are gaps in that data. Another example would be like, let's say that I owned a farm. I was actually raised on a farm, and so anytime that I wanted eggs, I would just go out and I might get pecked a couple times, but I would just get them just straight out of the nest and then go back to the house and cook them up. But I couldn't go outside and get 10.2 eggs, right? But I could go outside and get 8 eggs or 6 eggs or something like that. So types of data that can have gaps in it or holes in it, that's discrete data. It's countable, like with whole numbers and such. And it doesn't have to just be limited to whole numbers, but it's countable. Okay? Now, continuous data, if you think like a continuous function. So if data is continuous, then that means the data can take on any value within an interval. All right. And so what do I mean by within an interval? Well, there's some things that just aren't realistic. Like if we were measuring everyone's height in here, I'm not going to have anybody in here that's 500 inches tall. You know, that just doesn't happen. It just can't happen, right? So there is some interval on which we would be measuring heights, but there could be somebody in here that's 70.25 inches tall. There could be somebody in here that's 55.1 inches tall. So there are really no gaps there. Continuous means to continue on, and within some certain interval or with certain boundaries, that data has no gaps. Like if you went outside and you measured the height of a tree every day, you know, it's going to keep growing and keep growing. Yeah, eventually it's going to stop growing, but there's not going to be any value at which that tree's height could not be if you had very precise instruments. So that would be continuous. So continuous data is pretty much what it sounds like. Heights, weights, things like that, those are all continuous data. Now I know that scales usually will round off a pound or a tenth of a pound. I'm not looking forward to getting on those scales this morning. But, you know, weights generally are thought of as continuous data because there's no values. There's nothing that says when I step on that scale that I couldn't weigh 400 pounds or 402.35 pounds or something like that. So even though the scale may not measure it there are no gaps, is what I'm trying to say. All right, so really easy to understand discrete and continuous data. Now, 2.6 is on levels of measurement. I took a couple of graduate level statistics classes that were math statistics classes, and so I never really went through these levels of measurement until when I was working on my master's and I had to take a research class, and we went over levels of measurement for the first time. That's when I saw it, and in every statistics book that I've used now, I make sure that I cover these levels of measurement because they more than likely you're going to see these again. Okay, so we have 4 different levels of measurement, and they really rely on characteristics of the set of data. It's like what kind of stuff can we do with the set of data, and then that determines what type of or at what level of measurement that we're at. Okay, so the first level of measurement that we're going to talk about is the nominal level of measurement. All right, the nominal level of measurement is probably the most simple level of measurement, the easiest. In a nominal level of measurement, data that represent whether a variable processes said processes, I meant possesses, sorry. Some characteristic. Data that represents whether a variable possesses some characteristic. That's called nominal, or nominal data. So Nominal data would be things like data that was maybe male, female, maybe I had ones and zeros. Maybe I had 1 for female and 0 for male. And that's just my whole set of data, ones and zeros. Now, adding that data wouldn't make any sense, because 1 minus 0, well, while that may equal 1, that doesn't make any sense with our set of data. Another example would be like, maybe you were asked, are you Democrat, Republican, or Independent? So if you had a set of data that was all the answers were just Democrat, Republican, and Independent. There's no way to sort those. In your mind, you may think, yeah, my stance on things makes me a Republican, and so I know best, and so, well, no, you don't. I'm not saying that because I said the word Republican. It's just you can't really rank those in a set of data. Same thing, what if I went out in the parking lot and I wanted a set of data on the color of vehicles in the parking lot. And I just wrote all those colors down, you know, blue, red, gray, white, black, purple, orange, pink, whatever color cars are out there. And, you know, what could I do with that set of data? Could I sort it from greatest to least? No, not really. Could I say blue plus yellow equals green? Well, I might could do something like that, but that's not what I'm talking about. With a set of data, you can't really add, subtract, multiply, or divide anything and get some useful stuff out. That's the very simplest level of data, and that's called nominal data. Okay? Now, ordinal data, that's the next level of measurement. Represents categories. That have some associated order. And even though these definitions, those two definitions, like written down, look very differently, they're not very different at all, because we can have categories with nominal data, like Democrat, Republican, and Independent. But there's not some associated order. Sorry, I left my R off there. There's not some associated order with that data. But data like, how would you rate this class? 1, 2, 3, 4, 5. Of course, 5, right? Or say that the choices were very bad. Some of you may select that. I hope not. Bad, fair, good, very good. You've seen things like that. Those are categories, but they also have some type of order to them. Now, me taking your answers and my answers, and taking your answer from one question and adding it to my answer from the same question, that still doesn't make any sense. You know, good plus very bad doesn't equal average or fair or something like that. So we still wouldn't be able to do that kind of stuff with the data, but we could order the data. Okay? So it does have some type of associated order, but you still can't add them together and make sense of it. Not until you get to the next level of measurement can you actually start doing things like that. And it's the interval level of measurement. So the interval level of measurement is data that can be ordered and the arithmetic difference is meaningful. So being meaningful, what am I talking about there? Well, let's say that, what if I had a plug in my house that was messing up? It kept messing up the charge of my iPhone. And so maybe I want to take and measure the voltage coming out of that plug every day. And I measure it every day for a month just to see if it's the same voltage every day. Well, I can take what I got from day 2 and subtract day 5 and get a difference. That difference could actually be meaningful. You know, maybe it was, I don't even know what voltages I would be looking for, but let's just pretend one day it was 6 volts and the next day it was 15 volts. I could get a difference there. I could say, well, the difference is 9 volts, and maybe that has some meaning. Okay? So data, when you can do things like that, you can take differences, and it actually has meaning. That's on the interval level. So another example of that would be temperatures. Okay? So let's say that on one holiday, we'll leave the holiday unnamed, but let's say on that holiday it was 82 degrees. But then 3 weeks later, it was 25 degrees outside. And let's say I was taking that data and I was writing it down and I was trying, I could find differences. You know, I could say, well, hey, it was 65 degrees difference in those, you know, in 1 week to 3 weeks later, or something like that. So the differences would have meaning. Okay. Interval data also has one other interesting property. It has a property of an arbitrary zero value. In math, we use the word arbitrary sometimes. I'm sure it's used in legal documentation also. Arbitrary zero value. Everybody understands zero, right? The lack of something is nothing, right? Nothing is zero. I saw that on TV the other day. Well, the interval data doesn't have a natural zero starting point. What that means is, like with temperatures, you know, even if you have a child that's maybe in the 1st grade or kindergarten, and they say, well, what's the temperature outside the day? And you tell them, well, it's 80 degrees. And then a few weeks later, they say, what's the temperature out today? And you say it's negative 10 degrees. They probably wouldn't understand what you were talking about, right? Because usually at early ages, we don't understand negative numbers. Well, temperatures don't start at 0, right? They keep going in the negative direction. So there is no natural zero starting point. Something like a salary, that would have a natural zero starting point. So if my salary was $0, that just means that I'm working and I'm not getting paid. All right, but if let's say that I made $52,000 last year, well, that, you know, that's a value that it may go up and down, but it's not going to be below 0, right? It can't be. All right, so with the interval set of data, we do not have that starting point of 0. you can go below 0. Okay? Now, so that brings us to, I guess you could say, the most complex level of measurement, and that would be the ratio level of measurement. All right. Ratio data is similar to interval data, except that it has a meaningful 0 point. And the ratio of 2 data points is meaningful. All right, so things like adding, subtracting, multiplying, and dividing are operations that we normally do at the ratio level. And we do have a natural 0 starting point. You know, I couldn't do any division with the interval level in temperatures if the temperature was 0, because we can't divide by 0. Now, even though the natural 0 starting point, or that meaningful 0 starting point, is 0, usually, you know, that would not, I can't say it wouldn't ever occur in our set of data, but it's where the numbers start. They have to be 0 or greater. And so things like ages, things like salaries, those are usually considered ratio data. Okay. Now, qualitative and quantitative data. So data is either qualitative or quantitative. That's 2 ways to categorize data. So qualitative data is usually measured on the nominal or ordinal scale. Quantitative data is usually measured on an interval or ratio scale. Okay, so that's just 2 ways to categorize data. Now, if you ever get confused, I mean, I just think about these first couple letters. You know, qualitative is kind of, if you think of quality, quantitative, kind of like quantity. And so usually quantity makes me think about numbers that could be used, adding and subtracting, multiplying, dividing. So that would be on the ordinal, I'm sorry, that would be on the interval or ratio scale. All right. That finishes 2.6.